So my name is Roman, and I work at OneTap. I'm a machine learner, and at first I'm going to talk about OneTap and what we do, and then I'm going to present to you one basic example of machine learning. So OneTap is a fully automated accounting platform for self-employed. This means samostojni podjetnik in Slovenian. So we basically offer our users services that we do boring stuff for them, and they can focus more on their clients and on their work. So is any of you here self-employed? I see that a lot of you. So you know that it's hard to get a credit, a loan, and if you get sick, you don't have a safety net, and you basically don't know how much do you earn, because like on the end of the year, you need to pay back the taxes, and it's hard to know what is basically your profit is. So we are trying to solve that. So our main goal is to make self-employment better than employment. And to achieve that, we're going to build multiple apps, a suite of apps that will help self-employed to make their life easier, basically. So our first app, it's OneTap Receipts, which is basically expense tracking app, where user can take photo of their receipt, and we extract expense, vendor name, and so on for him, and we also fill in his tax return. This app is out for 1 year. We have it on App Store and on Google Play, and it was well accepted because we got like 250 five-star reviews. Now we are working on our second app, which is OneTap Tax, which will help the users to learn how much tax do they have to pay on the end of the year. Our backend is built on Ruby on Rails, so that's why we're here. We have 5 people working on backend. We use like every app JSON API. And our backend team likes to brag that they have 4.0 GPA. So enough about us, and let's go to machine learning. So what is machine learning? It's basically we get computers to act without being explicitly programmed. So you have training data, you pre-process it, you select the machine learning algorithm, and then you build the classifier, a model. And every new sample that comes in can be predicted with this model. So to show you what I mean with that, I'm going to guide you through one example where most machine learners start. It's a disaster that happened like 100 years ago when Titanic sank, and a lot of people died there. And you see what I have in bold here, that some groups of people were more likely to die than others. So that is basically a pattern. And for that pattern, we're going to try to build a model. So we have the data here. And we see that we have more columns, which we call features in machine learning, and the rows are samples. So for each passenger, we have age, which is simply age of the passenger, the cabin where he stayed, the embarked, where he started his journey. So S is for Southampton, C is for Shenburn, and Q is for Queenstown, which is not here. So basically, yeah?
Why survive the decimal?
Why is decimal? Yeah, I'm gonna come there soon. So basically, Titanic went from UK to France and back from France to Ireland. Yeah, but that's not the answer. I'm just gonna go after each column. So also we have fare, which is basically a ticket price, name of the passenger, parch is number of parents or children of the passenger. Passenger ID is self-explanatory. Passenger class, was he in first class or in third class? Sex, male or female. Siblings or spouses, so the number of them. And we have, like the gentleman asked here, survived. 0 is died, 1 is for survived. We also have the ticket ID. So I would just like to add here that we basically, that I see a pattern here. I see a pattern and I can write an if statement here. So basically if a passenger is male and he's in third class, this passenger will die. Why? Because we see that in first row, we see he's male, he's in third class, and we see that in last row. So I have one if statement. And then I can write another if statement for females. If I would look enough, then I could write that if statement. And then when I get more data, I can write another if statement and another if statement. And then I have a lot of if statements and I have a big mess. So that's not the right way to solve the problem. So that's why it's better to use machine learning here. So what is the first step? The first step is usually to understand the data. You take one feature, let's say I took the price of the fare here, and I grouped users, passengers by sex. So on the top chart, I have males, and in the bottom chart, I have females. So what we see here on the x-axis is the price of the fare. So what we see here, that a lot of passengers who paid less for ticket, a lot of them died, because the red is died and the blue one is for survived. So is that a good predictive variable? I say that it is, because basically we can just, with one attribute, we can predict all of these samples correctly, and we can separate them. But these samples here are harder because they all overlap. So we need to add more attributes, obviously. So then the second step is basically the most important step, and where machine learners spend the most of their time. Is the preprocessing step, and we start with cleaning the data. If a sample, a row of data has a lot of missing values, then it's better to remove it. Or if sample, we know that it's wrong, then it's better to remove it. Then we go to second step. It's basically encoding the attributes. Why we have to do that? Because machine learning is all about matrix multiplication, and we cannot multiply strings. So that's why we need to convert strings to floats or to integers. So let's start with sex. We convert male to 1 and female to 0, because we have like 2 options just for that attribute. Cool, right? And for embarked, we can do the same. We have 3 values, so we can convert Q to 0, S to 1, and C to 2, right? It's not okay. It's basically a mistake to do that, because we have, then the algorithm will think that C is more than Q, because we mark C with 2 and Q with 1. If we would have size of a t-shirt, where it's large, medium, and small, then we can mark that with 2, 1, and 0. Then the algorithm would learn that that is basically, that 2 is more than 1. But here, we cannot do that, and that's why we split that feature to 3 features for each value. And we see, because we have Q here, we mark here with 1. We have S here, and that's why I mark S, we mark here with 1, and so on. Then we go to next step. It's basically filling in missing values. Cool. We fill in the missing values, and we see that age is missing here, but we basically have 800 samples, so we simply take the median value for age, and we fill it for every sample. So we see that median value on Titanic was around 30 years. After that, we built a model. I picked here decision tree. I like that classifier a lot because it's very easy to explain. And if you remember at start, I talked about if statements. And basically, decision tree are if statements. But they are built with machine learning automatically. And we see the if statement that I was talking to you about before here. If sex is male and if class is third class, he will most probably die. Because if the blue line is basically higher than the red line, there is higher probability that the passenger will die. If the sex is female and the class is first class, then she will survive. And what we see here, that a lot of females which were in first class and in second class came alive from Titanic. And a lot of men who were, let's say, if you were in third class, you didn't have a lot of options. You would most probably die. And what is great here, when we get more data, we simply rebuild the model and we get this new tree. It's basically that simple. And we can also use the model to predict new samples. So that's it from Titanic. And then I'm just gonna show you one example that I'm dealing with at OneTap. So we were with our app, we are out like for 1 year, and we have 40,000 users who submitted 600,000 receipts. And we get 80,000 receipts every month. We need to categorize these receipts. So basically, is receipt about food, or it's about traveling, it's about gas, and so on. So what we did till now, we simply map the vendor name to category. So basically, if a receipt came from Starbucks, we simply marked it as food, because coffee, drink, and food is basically the same thing. If the receipt came from OMV gas station, we simply marked it as gas. And we know that this is basically not true, because OMV can also sell food. Because if you stop, you can buy a sandwich, but not just gas. So we had a lot of miscategorizations. Then we proposed another method, which is smarter to use machine learning, basically. And we include following features. The first one is user profession. So basically, if user is a builder and he buys material, he will probably use that material to sell, not to use it for himself. So we can classify that as cost of goods that are being sold on. And if we have an artist who buys camera, he will also use that for his business, not for his personal use. So we need to take that into account. We take vendor name. As I said before, if there is a Starbucks, we can mark it as food. We take date, because we saw that usually people fill gas more in Monday or in Tuesday. we take expense total, because if a passenger go to gas station and the receipt is for €5, we know that he's not buying gas. He bought a sandwich, most probably. And we also take tax with Google Vision API. So that's all about OCR. We take text, and it also improves the accuracy of algorithm. But it was quite hard to basically make the classifier, because we had a lot of miscategorizations. So that's why we needed to filter receipts and recategorize most obvious receipts. So basically receipts from Starbucks and so on. We have a lot of receipts from Tesco, which is basically like Mercator in Slovenia. And we all know that Mercator can sell everything, not just one thing. So these are harder. Then we simply trained the classifier on the receipt, and we improved the categorization. So basically we built a validation set with 200 receipts, with most basic receipts, and we test those receipts with the previous categorization and with the classifier, and the classifier was better. So that's all from my side. Do you have any questions? Yeah.
So the vendor name and the total, and that's everything is entered manually, or?
Yeah. So we have classifiers for that, to extract the vendor name from receipt, and the classifier returns the probability. And if the probability of vendor name is 99%, then we simply push it through. But if it's not, then people check the receipt that we are sure that it's correct. So basically, we employ people who check receipts where algorithms are not sure.
Okay. And all this, I mean, you're using standard machine learning pretty much. It's not done through like neural nets.
Not yet, but we are starting to using TensorFlow with deep learning, and we want to employ more of that soon. Yeah.
How often do you rebuild the model?
Yeah. So basically, whenever we rebuild the model, we make the report where we measure a basic accuracies that we require. So basically, like once on 2 weeks, we try. And we make the report that we know if the new data that we put in reduces the accuracy of the model.
So this is to avoid the overfitting?
To avoid the overfitting and mistakes which can arise with new data. So what can happen? Let's say if 1,000 users would change categories on the receipt to wrong categories, and we would put that to classifier, I'm sure that accuracy would go down. So that's why we make the report, and we always try to improve it a little bit or to keep it on the same accuracy as before.
Is this completely automatic?
No, we do that manually. Yeah.
Can you talk more about like how do you measure the precision of your models? How do you do this data?
Yeah, sure.
How do you know that your model is good? How do you
Yeah, sure. So it's quite hard to know that your model is good, because you usually use cross validation to measure accuracy of the classifier. But if you have many miscategorizations, then the model can predict the category correctly, but you have marked it as wrong. So you cannot just do that with cross validation. So that's why we also have the validation set, and we want that stays the same, because there we have most basic receipts. And we also, like for other classifiers, we create, let's say, a rock curve, and we also do graphs where we we increase the confidence threshold, and we draw that with coverage, basically how many samples we output. Because let's say when you make the classifier and you say that it can just predict a value if it is not 90% sure, then of course it will predict less samples, not all, because the most of the samples will not be over 90%. Okay?
Can you talk more like in terms of quality? What kind of pictures do you get? Like really good quality pictures that are easy to understand? Or you get all of
Yeah, sure. I can. Yeah, I just had.
pre-processing of images or?
No, basically we don't do pre-processing of images, but I can show like few receipts that I'm working on, because I just had a presentation a few days ago about that. Yeah, I think it's this one. Yeah, it should be. So let's say I'm also working on a classifier where I try to predict the vendor name from the pattern of the receipt. So if I show you this on example, you see here that this receipt is from Rontech. And if we look at the text here, there is nowhere Rontech name. There is nowhere in the receipt, but the classifier knows that it's Rontech. And how is that possible? Possible is because the Rontech receipt has, let's say, stars here and then numbers. And we convert that to alphanumeric. And let's say, like it has patterns on the receipt, and after we get the OCR text, we pre-process this text and we tokenize it, and the algorithm then learns that these are Rontech receipts. Or let's say I have the same example here. This is a Tesco receipt, and we see here that it has an error because the Tesco is covered. And also the classifier knows that it is the Tesco receipt because each receipt has the same footer. So that's also a problem that we are working on. And we see that this is like bad quality receipt because it's rigged a little bit. But that's more problem for Google Vision that for us, basically. Yeah. So that's about that. Do you have any questions more?
The models that you build, they are basically just kind of like tree structures with if statements in them, and then you build this in one system, and then you transform the model, serialize it in some way.
Yeah, we use random forest because it performs well. For category extraction that I'm working on, I'm using logistic regression, and we also use SVM. We are trying now to more use TensorFlow and deep learning, but our guys in our team like spent 1 month and they couldn't get to good accuracy yet. They are using convolutional neural networks, and we are not quite there yet. So
in terms of numbers, like how many pictures of Tesco receipts do you need? You need like 100 receipts to build your model, or you need like 10,000 of receipts? In terms of numbers, how many numbers you need to be comfortable?
yeah, so let's say for the classifier that I'm working for this one, I made a filter. So in the training set, I just let the receipt that has 10, so vendor needs to have 10 receipts so that we get a pattern. And when I lowered that number to 5, the accuracy was much worse. So basically 10 is a good number, and you need to play a little bit with that, so to see. And in this, I had like 180,000 receipts, and I can discover vendor name with 90% accuracy of on the data set with cross-validation. So it's pretty good. It's better than we expected. So now the second idea is like to put that classifier with neural networks, because they are good with pictures. And if we use neural networks, we don't need to do that part, because we can put the image directly to the classifier. So then we can have like two classifiers, and they each put a vote on the prediction. Yeah.
You use Python?
Yeah, we just use Python. We mostly, basically all classification algorithms that we have are with scikit-learn. We also now have more and more data, so we are also thinking about Spark. And of course, TensorFlow because of neural nets and everything.
Are you using that Orange?
No. Yeah, no. So I'm not sure if you know, but basically Orange now also uses scikit, because the problem with Orange was that basically machine learning in Python is based on NumPy. And NumPy is a library which has efficient data structures. And Orange wasn't based on NumPy. So that was the problem. And it also doesn't have support for sparse data. And if you work with text, you have a lot of sparse data. That means that you have a huge vector, let's say 40,000 features, and you just have one. You know, that is sparse data, a lot of zeros and little ones.
Why don't you also use the item names? For example, in receipts there says like a sandwich or something. You can use that to help to classify the model.
Yeah, you can use that, but it's extremely hard to extract that. So basically, if you want to extract a sandwich, we use algorithm for this, which is called term frequency in inverse document frequency, where you can basically put where you can basically extract the words that describe the text the best. So basically, if we would put just Tesco receipts into that algorithm, the algorithm would remove all footers and all headers, because each Tesco receipt has the same footer and header. So we would get that, but the problem with extracting the sandwiches that basically there can also be a mistake with the OCR, and it also would extract a lot of words which are not like a sandwich, but a san and a witch, you know. But yeah, it's a good idea. We're also thinking about that.
Okay, thank you.
Yeah, thank you. So guys, I just need to show you one more slide, because yeah. So we're hiring the backend Ruby developers. So if anybody has a friend, or if you're interested, just talk to us over the pizza place. This is our team. And this is us that are here. Nate is HR, and Vesna is there, is product owner of OneTap. So thank you.